Hi everyone, this is Mr. Zikri speaking. So guys, last time we discussed about effect of magnetic field on a moving charge, especially positive charge that is moving in a straight line. A charge moving in a straight line will be moving in a curve because of the force of magnetic field. So in this case, we are going to discuss about force on a current carrying wire in a magnetic field. I'm going to be very effective in this video. As you know that current is actually a moving charges. Moving charges over time is called current, because current is actually moving charges, so these charges will be affected by magnetic field. So in this case, the wire will be pulled by the force of magnet. So we are going to define the direction of the force. So to remind you, to make you understand, to memorize the direction of the force, we can use right hand rules. So here the thumb is the current, and then B by other 4 fingers, and then the force is by the direction of the palm. So from here we can apply this to another picture. So here the cross means the magnetic field move away from us or goes inside the paper. So let's see, I is upward, B goes away from us, so the palm of our hand will be directed to the left. Is that correct? Yes. This is F. And for the second picture, I by your thumb, B from north to south, and F direction of your palm. Got it? I'm going to draw you a picture of hand, and then you can draw the direction of current by the thumb I, and then the magnetic field by another 4 fingers, and then F is by your direction of the palm. Got it? Okay. To write this down, you need to pause this video and then write this down on your notebook. If you're already done, I'm going to continue to the next slide. So here in the next slide, we are going to determine what is the force depends on. So the force on the wire, as you know that the force on the wire will be affected by 3 quantity. First is magnetic field, second current, and the third one is the length of the wire. Here the force is in Newton, as always, magnetic field is in Tesla, current in ampere, length of wire is in meter, and then the angle between I and B doesn't have any unit dimension. So now I'm going to answer an example question. I want you to write it down. Okay, you can pause this video and then you can write it down. Okay, it's easy to do that. Okay, so let's solve the first question. The current through a wire that is 0.8 meter long is 5 ampere. The wire is perpendicular to a 0.6 Tesla magnetic field. What is the force on the wire? So here, let's read it again. The current is 5 ampere, and then the length is 0.8, and then the magnetic field is 0.6 Tesla. Let's write it down, given variable from the question. We have L 0.8 meters. We have current I 5 amperes, and then we have magnetic field B 0.6 Tesla. And then what is being asked? It is being asked the force F. So we can find F by applying that BIL sinus alpha. Oh, how about the alpha? Alpha is, because it is perpendicular, it is 90 degree. B is 0.6, I is 5 amperes, L 0.8, and sinus 90 equal to 1. I'm going to use calculator. 0.6 times 5 times 0.8 equals to 2.4. So the force acted on the wire is 2.4 Newton. Clear? Okay, now I'm going to move this upward so it doesn't wow, we have more space, right? Okay, so now the second question. A wire carrying a 5 ampere current is in magnetic field at an angle at right angles. Right angles means perpendicular to the wire. The length of the wire is 0.1 meters. The force on the wire is 0.2 Newton. What is the strength of the magnetic field B? So let's write down all the given variable. A current I 5 ampere, and then L 0.1 here, and F 0.2, and then alpha is right angle 90 degree. Now let's find what is the magnetic field B. Yeah, what is B here? So instead of finding F, we are going to find B. So F BIL sinus alpha. F itself is given 0.2 Newton. Yep. B unknown, I 5, L 0.1, sinus alpha 1. So we can divide two of the side by 0.1. We got B equal to 2 over 5 or 0.4 Tesla. Okay, you can pause this video and then write it down, this note, and then you can write down the question, and then you also can write down the solution. If you have already done, you can continue to the next slide. Okay, I'm going to go to the next slide. Here I'm going to show you how to find the direction of the force using right hand rule. Okay, I'm going to draw the right hand so you can try to find by yourself the direction of the force. Remember, the thumb is the I, and then this one is B, and the direction of your palm is the force. So look at here, I here, B from north to south, and then where's the F? F is directed downward. Now we have, for example here, write it down first and then try by yourself, and then pause this video. I'm going to give you the solution for this example, but do not continue this video if you haven't done the writing. You have to draw the picture and then guess where's the direction of the force, and then you can continue to play this video and then see the solution. Okay, so here is the solution. B goes away from us. I is thumb, B is forefingers, so F is direction of the palm. F. And then for B, I is the thumb, B is the forefingers, and F is going away from us. Now for the next one, I do the thumb, B forefingers. Okay, the direction of your palm is F, so F is going to us, goes out from the paper, going to us, going to us. Okay, the last one, I is the thumb, B is the forefingers, and then the I is upward, is the direction of the palm. Got it? Did you good? Did you get all the sample correctly? Good. Now for the next question, you need to do it by yourself. Okay? A 40 centimeter long copper wire carries a current of 6 ampere and weighs 0.35 Newton. A certain magnetic field is strong enough to balance the force of gravity on the wire. What is the strength of the magnetic field? So look at the picture first. Here is the battery. So the battery, you know that the longer the wire is, the longer one is actually positive pole, and then the shorter one is negative pole, and then the current flows through from positive to negative. So the current goes this way, or in this copper wire to the right. So let's draw the weight. The weight is directed downward, and then to cancel the weight, where's the direction of the force? Of course, the direction of the force should be upward. Now, what is the magnetic field strength? Okay, let's write down all the variable. Here is the L, 40 centimeter or 0.4 meters, and then current I, 6 ampere, and then what is it? F. Not F, it should be weight. Yeah, weight is 0.35 Newton. Now what should we do? Find B. So look at here, as you can see that F and Y cancel each other, So we can write down that the force and the weight should have the same value. F is BI times L. The weight is the weight. B here given, no, it is unknown. I is 6, and then L is 0.4. The weight is 0.35. So to find B, we have to divide 0.35 by 6 times 0.4. We can use calculator. 0.35 divided by 6 equal to that, divided by 0.4 equal to that. So it is 0.15 Tesla. Okay, for this time you need only to study about this. If you feel you need to repeat this video, you can repeat this video and then pause where you should to take note. And then I'm going to check your presentation. Abdan, Aldo, Aditya, Ilham, Gilang, Firman, Lutfi, Irfan, Mario, Danny, and Yusuf. I hope that you all watch this and then take a note. We are going to have some exercise in the class or experiment. So if you watch this video, we can spare more time in the class to do experiment. Do you want to do that? Okay, good. I'm going to close this video. Assalamualaikum warahmatullahi wabarakatuh.